Hello and welcome to this section of the MATLAB tutor. Here we're going to focus on scientific notation and how to use exponents in MATLAB, and we're going to roll this into sort of the order of operations and the basic arithmetic that we did in the last section. So in order to do an exponent in MATLAB, it's something you're going to find yourself doing all the time. So if you wanted to do 5 squared, you would put 5 and you would put a caret sign raised to the power of 2. This little caret sign is shift 6 on your keyboard. That means 5 raised to the power of 2. If you hit enter, 5 squared is 25. And so that makes sense. If you wanted to do 5 cubed, you'd raise it like this. If you wanted to do something crazy, 42 squared, 42 times 42, then you would get an answer like that. And that's basically how you use exponents in MATLAB. Now, let me show you something here that I really want to make sure you pay attention to. If I wanted to type the following thing in here, what do you think would happen? Negative 2 raised to the power of 2. Well, it's negative 2 squared, so we should get a positive 4. Negative 2 times negative 2. When you actually put it in here, you get a negative 4. So people look at this and they're like, what's going on, MATLAB? You obviously don't know math. But what's going on here is the way MATLAB interprets this, it's thinking about in terms of order of operations. When you think about what you have negative 1. I'll just type it in. This is what you've really typed in is negative 1 times 2 raised to the power of 2. This is equivalent to what I typed before. The negative sign out front is just negative 1 times that. So MATLAB is always going to do exponents first. That's the way algebra works, order of operations. You do exponents first, and then multiplication, division, and then addition, subtraction. Of course, if you have parentheses in there, it can make you do things first. So it's doing the 2 squared, getting 4, and then 4 times negative 1, you're getting negative 4. And that's why you get negative 4. So really what we were trying to do here is negative 2 squared, right? The number negative 2. So the way to force that to happen is you need to put negative 2 in your parentheses and then square it. What's going on here is MATLAB is saying, okay, something is being squared, and that something is whatever is inside of the parentheses, in this case negative 2, and then you'll get your positive 4 back. So if you're doing some calculation, where you're trying to do negative 34 squared, you got to resist the urge just to type it in like that. If you're really trying to square negative 34, come back here and wrap it in parentheses so that you'll get your positive answer. Okay, let me clear the screen. Now these exponents can be, of course, used along with calculations involving addition, subtraction. You can kind of mix them all together. So if you had something like 2 plus 3 squared, of course MATLAB will get the answer, and the answer is 11. Now the way it works is order of operations. It does the exponent first. 3 squared is 9. 9 plus 2 is 11. Right? So I can do, let's say, 5 times 5 raised to the power of 2. It's going to, well, let's do it times to the power of 3. It's going to do 5 cubed and then times this guy right here. Now you can mix everything with parentheses as well. What if I wanted to do 1 plus, this is a better example, 1 plus 2 to the third power. The way MATLAB does this is it does the 2 cubed first, gets 8, plus 1 is 9. Now if I alter this, I can do 1 plus 2 and then raise the result to 3, and you're going to get a totally different answer. See, they look very similar. The only difference is I've wrapped the 1 plus 2 in parentheses. In the first case, we cubed the 2 and then we added 1. In this case, we add 1 plus 2 to get 3. 3 cubed, 3 times 3 times 3 is 27. All right, so that's something to be aware of. Anytime you're typing in long calculations, if you know that you want something done first, you need to wrap it in parentheses. Okay, or if you have something large that you need to raise to an exponent, 3 plus 4, minus 19, or 18 times 33, and you're going to raise that to the power of 2, then you'll get an answer. And I'm going to modify this calculation to show you something else. Let me show you another quick trick while I'm thinking about it. If you would like to recall the last calculation, the last input that you made to MATLAB, press the up arrow on the keyboard. That's what I'm pressing now. The up arrow on your numeric keypad or on the arrow keys, press the up arrow, and up pops what I typed in last. If I press the up arrow again, I get the thing I typed before that. If I press the up arrow again, I get the thing I typed in before that, and so on. So I can cycle back all the way to the beginning, and then if I want to go back down, I press the down arrow, and I can get all the way back down to the most recent thing that I've typed in. This is super useful because we just type this long thing in, and let's say, oh, I didn't mean it to be 33. I just hit the up arrow, and then I change it to 34. And then I get my new calculation. So definitely put that in your back pocket, because whenever you're doing MATLAB calculations, you're frequently going to try something and then try a variation or try something else. So you might want to recall the last thing. That's the up arrow there. So what if you had this large thing and then you wanted to divide it by something? You know, to reduce any ambiguity, I would wrap this whole thing in parentheses, and then in the denominator I'd have 45 minus 88 or something like that. So this is going to calculate this large thing in parentheses, and then it's going to square it, and then that's going to be the numerator. The denominator is going to be given here, and then it'll divide those things. So basically the bottom line is that it follows the rules of algebra. There's nothing really new here. You should all know this already. It's just that when you type everything in, you just need to be careful, especially when you do things like -4, to the 40 to the second power. You expect a positive number, it gives you a negative number. So make sure that you understand that. Now, I'd like to call your attention to one of the calculations we got here, -8.51 E plus 003. This is MATLAB's format for scientific notation. So what this means is 8.5122 times 10 to the 3. What this means is you move the decimal point 1, 2, 3 places. So it's 8,152.2 is what it calculated for this guy here. So let me clear the screen. If you yourself are typing in scientific notation, because you have large numbers, which is very common, and then there's two ways to do it. If I wanted to do 2.5 times 10 to the 3, I could do 2.5 times 10 to the power of 3. And that literally is the way you would write it on your paper, 2.5 times 10 to the power of 3. MATLAB understands this. Of course, it's just math, so it just shifts the decimal place 3 spots and you get 2,500. If I want, let me hit the up arrow to retrieve the previous command. If I wanted to make it 2.5 times 10 to the -3, then I can just type in a negative sign in front of there, and then it's going to shift the decimal place 3 spots to the left, which is going to give you a smaller number. Typically, this is what I do. But let me show you something just to refresh your memory. Let me just type a large number and raise it to a large number. Well, that's infinity. That's too large of a number. Let's do something like this. MATLAB is going to spit out some scientific notation formatted like this, 1.7, blah, 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 e to the plus 0.17. You can format your scientific notation in that way if you'd like. 2.5, e is just the small letter e on the keyboard, plus, let's do 3, just to make it consistent. You could type it just like that, hit enter, and it understands that that's 2,500. Let me hit the up arrow to recall the last guy. Instead of e plus 3, I can say e minus 3, and then it'll be a smaller number. So it's whatever you want to do. If you want to say 2.5 e to the plus something, that's fine. If you want to say 2.5 times 10 to the 3, that's fine too. It's either way. It's completely valid either way. Just make sure that whenever you're typing this in, you remember that this e here has nothing to do with the mathematical constant e. It means exponent, or it really means scientific notation. It means power of 10. Is typically what you see in a calculator as well. So it has nothing to do with the constant e. So let me clear the screen. And before I leave here, I just want to take the time to introduce something that you'll use a lot, and that's the number pi. Pi in MATLAB is represented by pi, like this. It's not capital Pi. It doesn't know what that is. It's not little p and big I. It doesn't understand that. It's pi, like that. And it's, by the way, not pi. It doesn't understand that either. So you can use pi for pi anytime you want. Now, also just notice that MATLAB is using 4 decimals here. Of course, the number pi is infinite decimal. So MATLAB is when it's using the calculations, is going to use a really long and detailed constant for pi, but when it displays it back to the screen, it truncates the decimal points here, and we'll talk more about that later. So don't worry about the accuracy. When it uses the number of pi in a calculation like this, 2 times pi, it's using a very accurate number for pi, and it's only truncating the decimal spot to 4 places here for the purpose of the screen. So the reason I'm bringing this up now is because we're talking about order of operations, and you can mix pi in to this no problem. If you wanted 2 times pi raised to the 3rd power, instead of typing 3.14 in, then what you'll have here is you'll take pi to the 3rd power, then you'll multiply the answer times 2, and you'll get a number. You know, you can make this pi to the -3 power, right? What if you wanted to do something crazy? 2.2 times 10 to the power of pi. So the 3.14, the number for pi, is in the exponent there. You know, you can get something like this. So the number pi is just a number. Instead of typing in 3.14159, it just uses an internal representation for it here. So that's about all I want to say in this section. We have covered how to do exponents, you know, 4 raised to the 7th power. We said that you can make them negative exponents. We said that whenever you do this kind of thing, you need to be cautious whenever you have a negative number out in front. When you're doing an exponent like that, you need to be cautious because it's going to do the power first and then it's going to apply the sign. So if you really need it to be a -4 raised to the 7th power, you need to wrap it in parentheses. We've talked about scientific notation, the 2 ways to do it. You could say 3 times 10 to the power of 3. Of course, that's going to give you scientific notation. Or you could just say 3e to the plus 3. That's going to be the same representation of scientific notation. So get the hang of this, grab some parentheses, 2 plus 5 plus 6, you know, and then raise it to a power, and then add pi to it if you like. And MATLAB is going to follow the rules of exponents and scientific notation, just like the rules of algebra, to give you the answers. And so, of course, you can see your entire command history as we go back through here as well. The other thing that I really want to make sure you take home from this is that I wanted to introduce the keyboard shortcut. It's probably one of the most useful ones you'll have. When you want to recall the previous input, hit the up arrow on the keypad. You can scroll back through your input history. It's very convenient when you say, oh yeah, I want to try this again with a -6 and do something like that. So make sure you understand that and use it as you use MATLAB.